and the topic for today is aptitude and reasoning skills. I take immense pleasure in welcoming our guest speaker for today, Ms. Shabana, for handling the session. So before we go to the session, I request the student participants to make note of the tactics or shortcuts or tips what our guest speaker is going to give you today. And before we go to the session, Shabana ma'am, I just have two requests. Number one is handling or appearing for aptitude test is a bit difficult for the students by means of managing the time. And of course, because of this pandemic, anyways, the aptitude is not going to be a pen paper test. It is going to be an online test paper, and it is a preset timing on the screen. So based on that time management, they are supposed to complete this aptitude test paper. So give us some tips, how to handle this aptitude by means of time management. And number two is they might have some negative markings also. Some companies, they may give negative markings. So in that case, if you could give some tips on what questions the students can target, be smart enough in appearing for, and since it has some negative marking, what questions probably they can omit, some kind of tactics. And number three is aptitude is comprises of general aptitude test comprises of 5 different topics. Number one is quantitative aptitude. Number two is logical reasoning. Number three is verbal ability. Number four is general knowledge, and number 5 is technical skills. So now in this aptitude, we are covering the first part, quantitative aptitude. So I would request you, ma'am, to share some topics that comes under quantitative aptitude, because there are a lot of topics under quantitative aptitude, like profit and loss, percentage, some kind of critical thinking, logical reasoning questions. So a lot of topics under quantitative aptitude. Since the session is very short, we cannot cover all the topics, but we can at least give topics which will come under aptitude for the students, for them to get into detail and prepare themselves for the appearing for the aptitude test. So over to you, Shabana ma'am.
Sure, ma'am. Thank you very much, at least for giving me the insight, about the requirement. So definitely at the end of the session, I would take immense pleasure in sharing all those, clarifications. So as of now, for today, we are going to see, since it is going to be the last day, we started with shortcuts, we started with squares, we started with cubes, and we saw square roots, cube roots, few applications. We covered a little bit of percentages and so. So today, since as I told you, it's going to be the last day, I thought I could, take the students forward towards 2 very, very important topics. Okay. Now, as far as aptitude is concerned, you have this footsteps of aptitude in almost all the placements. Like when you take campus placements, if you're going to go for any competitive exams, so wherever this is going to be your entry ticket to get into the job. So again, now as you said, like quantitative aptitude, reasoning, verbal ability, and etc. So I thought I can take the students towards the reasoning part, which is going to be the very, very important part of any competitive exam or campus placements. So you take any competitive exams, campus placements, the topics which we are going to cover today will definitely be a part of it. At least you can take some 6 or 7 marks out of them. Okay, so those topics are, one is that analytical reasoning, and the second one is that cubes and cuboids. All right, now before going into the topic, before going into the problems, I would like again to take the students through a puzzle as usual. Okay, so this puzzle is going to imply a greatest knowledge about your, analytical reasoning. So the puzzle is all about Mr. Grand Slam Cooper. So the puzzle is all about Mr. Grand Slam Cooper. Now he owns a sports shop called Hit and Miss Sports Shop, and he wanted to buy 150 balls for his sports shop. I'm gradually moving towards the problem. So it is about Mr. Grand Slam Cooper, who owns a sports shop called Hit and Miss Sports Shop. So he wants to buy 150 balls for his sports shop. Now what happens is he chooses 2 different colors. Let's take one as black and the other one as white. Okay, he chooses two different colors for his sports shop. So he wanted to buy 75 black color balls and 75 white color balls. So comprising of 150. So I repeat, he wanted to buy 150 balls, out of which 75 are black and 75 are white. Now it's very clear in his perception. Now he wanted this 150 balls to be arranged in three different crates. So crates are nothing else but just boxes. So he wants this 150 balls to be arranged in three different crates. So ultimately it means that each crate hold 50 balls. So there are 50 balls in each crate. Assume these are the crates and it has 50 balls in each. All right. So 50 balls. Now he also gives specification saying that he wants 50 number of black color balls in one crate, 50 number of white color balls in the other crate. And of course, see, when you take 50 black color, you have 25 black remaining, and 50 white color, you have 25 white remaining. So 25 and 25. So black and white comprises of 50 mixed colored balls. Okay, so I repeat the puzzle again. So he orders 150 balls, wherein 75 are black, 75 are in white. So he takes 50 balls, 50 black color balls in one crate, 50 white color balls in one crate, and 25 black and 25 white in the next one. So there are three crates which has been packed with all the 150 balls. Now it is the shipment of the balls which are coming in. Now before this person go and receives it, he's getting a call from the place where he had ordered saying that, sir, as per your order, all the three crates are dispatched. But there is a small problem. All the three crates are mislabeled. Okay, this is a very, very important word here. So all the three crates are mislabeled. Now, what do you mean by mislabeled? Mislabeled are nothing else but you are wrongly labeling it. Say, for example, the box which has black color balls may be labeled as white or mixed. The box which has white color balls may be labeled as black or mixed. So none of the boxes carry the correct label on it. Okay, all the three boxes are mislabeled. Now, this person who Mr. Grand Slam Cooper, he's a puzzler of great renown. So he comes up with a puzzle saying that, see, you can take, that is, he can himself take any one ball from any one of the three crates. You have three boxes before him. So he can take any one ball from any one of the three crates. So the ball that he takes may be black or white. We do not know. So the ball that he takes may be black or white, depending on the color or based on the color of the ball that he takes up, he have to correctly label all the three crates. Okay, I repeat, imagine you have three boxes before you. All the three boxes are labeled as either black, white, or mixed. Some labels are there, but none of the boxes carries a correct label on it. So you can take any one ball from any one of the three crates. So with the color of the ball to guide you, you have to correctly label all the three crates. Okay, so how do you or from which box do you take a ball in? And suppose if that comes to be black or white, whatever the color is, how do you correctly label on it? So this is going to be our greatest challenging puzzle for the day. Okay, now I am going to erase everything. I'm just going to display only the important part here. So let's forget about Mr. Grand Slam Cooper mislabeled everything. The puzzle just resolves very simple. Okay, you have three boxes before you. So here are the three boxes. So the boxes are labeled as, say, black, white, and mixed. There may be, I mean, the order may not be the same. It can be white, mixed, and black, or mixed black and white, whatever the order is. So the order doesn't matter here. So you have three boxes before you, which are labeled as black, white, and mixed on any one, I mean, on each of the boxes. So all the three boxes are mislabeled, which means that none of the boxes carries the correct label on it. Now you have to take a ball from any one of the three crate. Okay, so with the ball, with the color of the ball to guide you, you have to correctly all the three boxes. For example, now let me choose this. So suppose if the ball that you are taking from this box, you are choosing this box, and most importantly, now before you choose a box and take a ball from it, there are three important things that you have to notice. One is that all the three boxes are equally weighed. It is not that black is lower weight, white is, it costs weight of higher challenge. So you can, weigh the box without opening it and say or label the correct boxes. No, it's not so. All the three boxes are equally weighed. Second point is that all the three boxes are made out of perfect wooden, they are perfect wooden crates. It is not that they are transparent, so you can just see through it and guess the color of the ball. So it's not that way. And above all, okay, above the 2 points, the most important is that when you take a ball from the box, you just have to leave your hand inside, take a ball, see the color of the ball, and that has to guide you to correctly label all the three. And it is not like you can peep into the box, see the color of the balls, and label it. It's not that way. So I mean to say that it's a very, very perfect logical question, which is going to give you a brightest light to solve problems of this sort, that is problems of analytical reasoning. So let me go for one example. Maybe you're going to take a ball from this box. Imagine that you are choosing the box which is mentioned as it has black color balls, that is, it is black labeled. So you're going to choose a ball from this. So you take a ball. Suppose if that is black. Okay, suppose the ball that you took is black in color. So what does it mean? So here you have black color balls. I mean, you have black color label and you are taking a black color ball. I say the label is, I mean, it is wrongly labeled, which means that it cannot have black color balls, but you have taken a black color ball. So which means that it may be mixed. So here you can confirm, suppose if the ball that you are taking is black in color, you can confirm that this box is not black, but it is mixed, because you don't have a possibility of getting white because you've taken a black color ball. So it cannot be only black because it is wrongly labeled. So it cannot be black labeled. Okay. So it can be mixed. So you can come to that conclusion. But on the other side, on the contrary, suppose the ball that you have taken is white in color. You cannot judge that. You are just taking a ball. It may be black or white. So if it is black, you can say that it is mixed. But suppose if it is white, how do you confirm? So it can be either white or mixed. So you cannot come to a conclusion. So the problem moves in this way. So can you identify or can you find and tell me, like, from which box will you take a ball, and what, I mean, if the color of the ball to be black, how do you correctly label it? And if the color of the ball to be white, how do you correctly label it? I'll give you just a couple of seconds. I want you all to just think about it and give me the answers.
Ma'am? Ma'am?
Okay, Prakriti, you have anything to say?
Yes, ma'am. I'd like to answer.
Yeah, please.
So, ma'am, I think maybe if we go with the mixed box next, and if we pick a black ball first, we can label it as
Okay.
the black box since it's been wrongly labeled.
Very good, very good. So you're on the right way, that you are. See, it's very, very simple. Okay, I'll resolve the problem in the most easiest way. The box which is mentioned as it has black will not have black color balls. Instead, okay, the box which is mentioned as it has black may have either white or mixed. So these are the possibilities. I'm going to write down all the possibilities, okay, and then go by the elimination process, a simple elimination process. So the box which is mentioned as it has white will not have white color. Instead, it can either have black or they can be mixed. Now, the box which is mentioned as it is mixed will not have mixed. It can either be black or it can be white alone. Okay, so we are just drawing the possibilities, and after which we go for the correct answer. I do not touch these two boxes because it has a possibility of getting into the mixed option. So I don't, not even touch these two boxes. I'll directly jump into box 3, which is mentioned as it as mixed. Because a box which is mentioned as it as mixed will definitely not have mixed. It can either be black alone or it can be white. So suppose the ball that I'm taking is black color as you suggest. Okay, suppose the ball that you have taken is black in color, you would say that this has only black color balls. And if it is black here, it cannot be black because black is already labeled here. So it cannot be black. It can only be mixed, or it can only be mixed. So if it is black and mixed here, you have only one option left, which is white. So you go for white here. Very good, Pragati. It's a great, wonderful answer. On the contrary, or on the other side, suppose that the ball that you have taken is white in color, you would say that this is white. And here it cannot be white because white is already there. So it should be mixed. So white and mixed have taken place. So it can only be black here. So ultimately, I would like to say that even though the problem looks little complicated, the solution is very simple just by elimination technique. Okay, so this elimination technique is going to play a vital role when it comes to analytical reasoning. Okay, I tell you what analytical reasoning is. Um, analytical reasoning is a problem where you have complete data with different verticals. Now, what do you mean by verticals? See, a verticals is nothing else but a group of data. For example, let's read this problem. I'll read this problem for you. There are five different people. Okay, Manish, Ashish, Rahul, Kapil, and Praveen. They live in five different places: Lucknow, Mumbai, Kolkata, Delhi, and Pune. And they are of five different professions, which are architect, doctor, engineer, artist, and musician. Now remember, none of the vertical, now these are called as verticals. All the names is one vertical, all the places is another vertical, and all the professions is a third vertical. Now, none of the verticals are correctly arranged. It means that it doesn't mean that Manish lives in Lucknow and he's an architect. Ashish lives in Mumbai and is a doctor. Rahul is an engineer living in Kolkata. No, it is not in that way. So none of the data are in the correct order, necessarily, not necessarily in the right order. So which means that the data are shuffled and you have a lot of clues beyond. So with the help of the clues, you have to correctly match the names with the places and the professions. So this type of problems are called as analytical reasoning or data arrangement. Okay. So here is that you have three verticals, as I told you. So the names are all one vertical. The places is all your second vertical, and the professions is all your third vertical, right? It is not necessary that you have to have only three verticals. You may also see problems with four verticals, five verticals, six verticals, and so. Okay, and I've also seen problems with just two verticals, right? So depending on the problem and depending on the number of verticals, you have to correctly arrange all the, depending on the clue, you have to correctly arrange all the verticals in the right order. So we are going to see one such example. The reason why I took this example today is that it carries a lot of negative clues. Now, what do you mean by negative clues? Now, when I say Manish lives in Mumbai and he's an architect, so that's a positive clue. So you match all the three verticals together. So Manish is in Mumbai and he's an architect. Very good, that goes through. But when I say Manish is not an architect and he does not live in Mumbai, you would term that as negative clue. So this is a problem with all negative clues. If you read this problem out, you will know. I'll read this problem for you. See, I've just mentioned it in short. PR is Praveen, RA is Rahul. So Praveen and Rahul are not or do not live in Lucknow or Pune. The cross means that they do not. So Praveen and Rahul do not live in Lucknow or Pune, and neither of them is an architect or doctor. Manish and Ashish are not artist or engineer, and they do not live in Delhi or Lucknow. So can you understand? You have a lot of negative clues here. Then Kapil is not a doctor. Kapil is neither a doctor nor a musician. His profession is not into doctor or musician. The person living in Lucknow is not an artist or an engineer. So the person living in Lucknow is not an artist or engineer. So for this, you have to identify who lives in Lucknow only, then you can say. Now, the Manish does not live in Kolkata, and Ashish is not the doctor. The next clue is that the musician does not live in Pune or Mumbai. Next, Praveen is not an artist, and the artist does not live in Delhi. So if you could observe all the clues, almost you have 1, 2, 3, 4, 5, 6, and 7. So you have 7 clues, but all the 7 clues are of negative clues, right? So this is the reason I choose this problem. I'll tell you how to solve this. Okay, post which maybe you will have a clear picture on how to solve analytical reasoning. You can take a lot of I'll give you a few websites also, so you can take a lot of problems from there, solve and see. Okay, so let's move into the problem now. So there are different strategies to solve. Okay, you have different strategies to solve. One simple strategy is to go by your tabulation. Okay, so even in tabulation, you can take 2 different tabulations, one on the, 2 tabulations on the horizontal part, one on the vertical, or 2 on the vertical and one on the horizontal. But I am not going to confuse on any of these, strategy today. I am just going to take only 2. Okay, you can choose any 2 out of 3 because you have 3 different verticals. You can choose any 2 verticals out of which put it in the put it on the horizontal and vertical part. So the one I'm going to choose today is definitely the names, because when you could observe all the clues, almost all the clues would mention name here. So I'm going to take definitely names on one side. So with the names, you can either choose the places or the professions. So let me take all the names here. So the names are Praveen, or let me just start with Manish. Okay, Manish, Ashish, then Rahul, Kapil, write it in a Manish, Ashish, Rahul, Kapil, and Ravi. Okay, so I'm going to draw a table. Now with this, as I told you, you can take any, either the profession or the places. That's again your choice. Now today, Pragati, do you have any choice to take? Either the place or the profession? Okay,
Ma'am,
so
so
I
we
can't.
can,
Ah,
yeah, so ma'am, we can like randomly choose any profession and any location.
okay, so we can go with professions, as she said. So I'm going to
Yeah.
take the professions here. So architect, okay, doctor, engineer, artist,
Artist and
and
musician.
musician. Okay, so I have taken the names on one side and professions on the other side. So I have names and professions here. So I'm going to number the places down. So I have Lucknow, then Mumbai, then I have Kolkata, then Delhi and Pune. Okay, so I'm going to number them. Number Lucknow as 1, 2, 3, 4, and 5. So I have numbered all the places. So that, I did not confuse with the places again. I'll just go with the numbers, take it off, eliminate, and just cross. So now the first clue is Praveen and Rahul do not live in Lucknow or Pune. So it's Praveen and Rahul. Okay, they do not live in Lucknow or Pune. Lucknow is number 1 and Pune is number 5. So Praveen is not in 1 and Praveen is not in 5. Similarly, Rahul is not in 1 and Rahul is not in 5. Okay, so Praveen and Rahul do not live in Lucknow or Pune. We are done. And neither of them is an architect or doctor. So you all know neither means they are not an architect and they are not a doctor as well. So they are not architect and they are not doctor. So both of them are not architect and doctor. So I'll put a cross. Then Manish and Ashish are not artists or engineering. So it's about Manish and Ashish. They are not artists and they're not engineers. So Manish Ashish is not an artist and engineer. Okay, so Manish and Ashish are not artists and engineer, and they do not live in Delhi or Lucknow. Now Delhi is number 4, Lucknow is number 1. So both of them are not in 1 and not in 4. They are not in 1 and they are not in 4. Now if you could observe all this, you don't have 1 here, you don't have 1 here, no 1, no 1. So possibly Kapil belongs to Lucknow. So I'll place Kapil for Lucknow and cross off 1 here. Okay, so the Kapil is a person who is living in Lucknow. Next, Kapil is not a doctor nor a musician. So Kapil is not the doctor nor the musician. So Kapil is not the doctor nor the musician. The next clues are the person living in Lucknow is not an artist or engineer. So of course, the person living in Lucknow is Kapil. He's not an artist and he's not an engineer. So if you could see again, Kapil, you have no possibility towards doctor, engineer, artist, and musician. So of course, Kapil can only be an architect. So I'll put a box for Kapil with architect matching and put number 1 here, which means that architect cannot be Manish or Ashish. Okay, since you couple architect for Kapil, since you match architect for Kapil, it means that architect cannot be Manish or Ashish. So we'll put a crossover. Now this is done. Next, Manish does not live in Kolkata. So Manish does not live in Kolkata. Kolkata is number 3. So I'll put a crossover. Manish does not live in Kolkata. And Ashish is not the doctor. Now suppose Ashish is not the doctor. If you could see the table, you can easily conclude that Ashish has only one box left, which is for musician. So Ashish can only be the musician here. Now I'll put a crossover for musician, which means that musician cannot be either Praveen or Manish as well. So we are crossing over. And again, if you could see this box, okay, this line, Manish has only one box left, which is for doctor. So I'll confirm doctor for Manish. And again, the crossover is already there. So when it comes to Rahul and Praveen, you have boxes, engineer and artist still pending. So we will just put it on hold. Okay, so we next. So Manish does not live in Kolkata and Ashish is not the doctor. We are done. The musician or Pune. The musician does not live in Pune. Now, who is a musician? Musician is Ashish. He does not live in Pune. So Pune is not for him. Pune or Mumbai. So Pune is number 5 and Mumbai is number 2. Now, if you take, you don't have 1, 2, 4 and 5. You don't have any of these numbers. So you only have one number left, which is 3. So I'll put 3 for him and take over 3, cross over 3. So 3 is not possible here and 3 is not possible here, right? So now again, if you could just observe, you have 1, 4 and 3. You have two numbers left, which are 2 and 5. Okay, so here you are done. So here again, you have two numbers, which are 2 and 4. So 2 and 4, 2 and 5. Now let's just confirm. And here also you still have 1, 3 and 4 is over. So 2 and 4 is still there. Now let's say Praveen is not an artist. So Praveen is not an artist. So of course, Praveen has only one box left, which is for engineer. So you put a box here and cross over. So only one box left. So you put a box here. So Praveen is not an artist and the artist does not live in Delhi. So who's the artist now? Artist is Rahul. He does not live in Delhi. So he is not for 4. He has only one
Hello.
left, which is 2.
Hello, Shabana,
Okay,
ma'am. Sorry
so
to
the artist does not live in Delhi. So Delhi is
Hello.
number 4. You strike off 4. You have only one option left, which is 2. So you put 2 here. So since 2 has already taken place, you take off 2. So you have only numbers which are 4 left for Praveen and 5 left for Manish. So now you confirm. So you have all the 5 clues with all the places and all the professions ready. So Kapil is number 1,
Hello, ma'am.
Lucknow, and he is an architect. And then number 2,
Hello,
Rahul.
Shabana, ma'am.
Rahul lives in Mumbai and he is the artist. So number 3 is Ashish. Ashish lives in Kolkata and he is a musician. So number 4 is Praveen. Praveen lives in Delhi and he is the engineer. And finally, you have Manish. Manish is the doctor and he lives in Pune. So you have all the verticals which is being rightly matched. See, it is not necessary that you have to take only the professions here. You can also take names on one side and places on the other side. Put it in the same way. Like, put the professions with numbers 1, 2, 3, 4, 5, solve and see. You will get the correct answer. Okay.
Ma'am,
Even,
excuse me,
see,
Shabana,
if you
ma'am.
are
Can you?
smart enough, you can also take only the professions and the places matches with the names and see. You will anyways get the correct answer. So this part is called as analytical reasoning. Now, when you take, any like any competitive exams for consideration, you definitely can easily score 5 marks from problems like this. Okay. Now, Pragati, do you have anything to say?
Hello, ma'am.
Yes, Pragati.
Yeah. Ma'am, can you please explain the last part alone? Like when you're talking about you're assigning the numbers to all the people and the professions.
Yeah, sure,
And
Pragati. Just give me
ma'am,
a
the
second.
board is also not fully visible, ma'am. So we were not able to see
The
the
board is not
first.
visible, is it?
No, we were not able to see the first two lines of the question, the names and the location.
Oh, okay. How about
Yeah.
now, Pragati?
Yeah. Now it's fine, ma'am. Now it's better.
Okay, fine.
Yes, ma'am. Now it's fine.
All right.
Thank you.
So Pragati, can you please repeat? You want me to say the last clue, isn't it?
Yeah. Yes, ma'am. Yes,
Last
ma'am.
in sense, like okay, the last point is this. See, Praveen. Okay, the last two clues are the musician does not live in Pune or Mumbai. Okay, one second. Let me just check. Pragati, is the board visible now? Can you see the entire problem?
Yes, ma'am. Now it's visible.
Pragati, can you see the entire problem, Pragati?
Yeah, now it's visible, ma'am. It's visible now, ma'am. I
Okay,
hope you're able to
fine.
hear me.
All right. See, I repeat the last two points alone. So the last 2 points are this: the musician does not live in Pune or Mumbai, which means that we have identified who the musician is. So he does not live in Pune or Mumbai. So accordingly, you put a cross and you will find out where the musician lives. And Praveen is not an artist. The artist does not live in Delhi. So Praveen, if he is not the artist, he must be of the engineer only, because you only had artist and engineer pending. So if he's not the artist, he must be an engineer, and the artist does not live in Delhi. Finally, we found out who the artist is. The artist must have been Rahul. So since you say he does not live in Delhi, okay, the artist does not live in, so that he does not live in Delhi. So if he is not 4, you have only 2 options, number 2 or 4. If he's not 4, ultimately you eliminate 4, you have only one option left, which is 2. So if you fix 2 for him, you don't have possibility of getting 2 for this fellow, I mean for Manish. So you take 5 for Manish, and of course not 2 for Praveen, and 4 for Praveen. I mean, yes, of course you take 4 for Praveen. So it is nothing else but you just eliminate and find the answer. Okay, is it clear?
Yes, ma'am. Clear now. Thank you so much. Ma'am, are you able to hear me?
I'm sorry, Pragati, can you please repeat?
No, ma'am. I said that it's very clear now, and thank you. Thank you for explaining it
Okay.
again.
Yeah, good, great. Thank you so much. Okay, so this is what analytical reasoning or data handling all about. So as I told you in the beginning, it is not necessary that you have to have 3 verticals. You may even find a problem with 2 verticals. May you have 4 verticals, 5 verticals, and so. So all that you have to do is, eliminate and find. So elimination is the only technique to solve problems of this sort. So next is that we are moving towards, cubes. Okay, so before moving into the cubes, I would like to tell you one again puzzle. Okay, let's say you are going for a birthday party. So you are going for a birthday, your friend's birthday party. So of course, what comes into your mind when you think about a birthday party? So birthday party comprises of cakes. Okay, birthday party comprises of cakes, right? So imagine that you are, your friend has asked you, or she or he has seeked the help of getting a cake for his or her birthday party. So you are about to buy a cake. Now you also, he or she also gives you some suggestions saying that, she wants the cake to be in a cube shape. Okay, so here comes your cubes. Now, what do you mean by cubes? The day-to-day cubes that you have seen, you must have seen dice. Okay, you're playing Ludo die, and your room itself is a cube. And you must have seen many boxes, cubical boxes, or fruit boxes. So anything like that. So a cube is a square in a three-dimension figure. So this is how your cube looks. So it's a cube, a square in a three-dimension figure. So imagine you are buying a cake for your friend's birthday party, which is cubical in shape. And let's take any three different cream flavors. So let it be, say, butterscotch. Let it be butterscotch. Then you have strawberry and what else? Any other suggestions? Butterscotch, strawberry, and you can take chocolate. Okay, so you have three different flavors of cream on all the sides of the cube. Let's say this side is butterscotch cream. This is also butterscotch cream. Here you have strawberry cream. Here you have strawberry cream. And here you have chocolate cream. And here you have chocolate. Okay, so you have a cubical shaped cake with butterscotch cream, strawberry cream, and chocolate cream. Okay, so it's a big cube. I mean, a big cubical shaped cake you have ordered for your friend, and it's the big day that you are, taking the cake for her birthday party. Now let's say there are ultimately 512 guests. Okay, for the function. So it's the big party where there are 512 guests for the function. So your friend wants to treat all the 512 guests equally. Okay, your friend wants to treat all the 512 guests equally. So what she says is she wants to divide this cake into 512 smaller identical cubical pieces. Okay, so she says that you want to divide this cake into 512 smaller identical cubical pieces. Okay, smaller identical cubical pieces of cake. Okay, so you are also, you are helping her to cut the cakes into 512 smaller identical cubical pieces of cakes, and you have given it to all the, you've distributed to all the 512 guests. It's over. Now, there's a question between you and your friend. So I repeat, now what happens is that you are ordering a big cubical shaped cake, okay, with creams layered in this way. So you have butterscotch in these two sides, strawberry in these two sides, and chocolate in these two sides. Now you are dividing this cake into 512 smaller identical pieces of cubical shaped smaller cakes, and you have distributed to 512 guests. Now what happens is, there's a question between you and your friend. Now, how many guests among these 512, how many guests will be there who have received the smaller pieces of cake, okay, without cream on any of its sides? So, of course, the smaller pieces is also in the same shape. It's in the same shape, right? So, this is the shape of the cake that you are giving. Perfect cubical, smaller identical pieces of cakes you are giving. So, how many guests would have received, okay, cakes in this shape where you don't have cream on any of its sides, none of its sides as cream. I hope you understand the question. Okay, so you are giving 512 smaller pieces of cake to all the guests. Now, how many guests would have received smaller pieces of cake with none of its sides creamed? Okay, so think about this question for a while, which gives you the answer for cube's shape. Okay, now let me answer. Forget about this problem as of now. So maybe when I explain you the concepts of cubes, post which will be able to give the answer. So forget about this problem as of now. Let this problem on be hold. You can also give the answers. Maybe through live chats also you can give the answers. And Pragati, if you get to know the answers, if you get any answers, please let me know. Okay. So let's take one, forget about the cubes as of now. So I mean the cakes as of now. So we are moving into the concept of cubes. By knowing the concept, you will get to know the answer for the cake problem. Okay, I'm taking a bigger cube, right? I'm taking a bigger cube. I'm dividing, or I'm giving a paint. Let in this particular problem, let me just give one proper color, one single color. In the cake problem, I gave you three different colors or flavors. Here I'm going to give only one simple color. So I'm dipping this cube into a red paint, taking it out, making it dry, and dividing this into say I can divide this into 27 smaller identical cubes. I can also divide this into 64 smaller identical. I can divide this to 125. I can divide this into 216. I can divide this into say 343. I can divide this into 512. I can divide this into 729, and I can divide this into 1000 smaller identical cubes. I can divide, see, if I'm going to divide into smaller identical cubes, I have to divide by any one of these numbers. Of course, other things are not possible. So these numbers are nothing else but, I hope by seeing the numbers you can find out, these numbers are nothing else but your cube numbers. Okay, so you are dividing this into 27 smaller identical cubes, or 64 smaller identical cubes, or 125. So which means that they are your cube numbers. Now let's stick on to one simple number. So you are dividing this into 27 smaller identical cubes. Pragati, you have anything to say?
No, ma'am. Okay. No, ma'am. Nothing to say.
All right, all right. Fine. So you are dividing this into 27 smaller identical cubes. Now, after dividing, I want to find out now how many smaller cubes are there among this 27. How many smaller cubes are there which are three faces painted? So how many smaller cubes are there which are three faces painted? How many smaller cubes are there which are two faces painted? How many smaller cubes are there which are one face painted? And how many smaller cubes are there which are no face painted? So this is what we are going to find out. Okay. So I repeat, you are taking a bigger cube, dipping into a paint, taking it out, making it dry, and then dividing this into 27 smaller identical cubes. Now, among these 27 smaller identical cubes, you're supposed to find out how many smaller cubes are there which are three faces painted, two faces painted, one face, and no face painted. Okay. So to know this, see, for smaller numbers, I think it's very easy. You can just draw all kinds of bubbles in the airs and find out the answer. But if I'm going to give you a bigger number, it's going to be a little challenging. So that's why we go for a strategy, and to know that strategy, you have to know how many corners are there in a cube, how many edges are there in a cube, and how many faces are there in a cube. Okay, you must be knowing that there are 6 faces. So a face of a cube is nothing else but this, a side. So 1, 2, that's like 3, here 4, this is 5, and the bottom one is 6. So you have 6 faces, and a place where 2 faces meet is an edge. So this is one of your edge. So 1, 2, 3, 4. Same way you have the other side, 5, 6, 7, and 8. Okay, and then you have this one 9, 10, 11 and 12. Okay, so you have 12 edges, and a corner is a place, of course, where three faces meet. So this is one of your corner. So 1, 2, 3, 4. Similarly, you have 5, 6, 7 and 8. So you have 8 corners. A cube will definitely have at any cost 8 corners, 12 edges and 6 faces. So this is not going to change. Now what happens is, now you are dividing this into 27. So to know how the cube is being divided, you equate this to n cube to find the value of n. So you equate this to n cube to find the value of n, and the value of n is 3, of course, which means that there are n minus 2 lines across each and every face, horizontally and vertically. Okay, so if your n is 3, it means that you have n minus 1, sorry, it is not n minus 2, n minus 1 lines across every face horizontally and vertically. So n is 3, n minus 1 is 2. So you have 2 horizontal lines and 2 vertical lines. Okay, similarly, 2 horizontal lines and 2 vertical lines. 2 horizontal lines and 2 vertical lines. Okay, so this is how the cube is being divided. Now, if you could just imagine, this is one of the cube, this is another cube, and this is another cube. You can take this all separately. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 plus 9 plus 9 gives you 27. So this is how you must have divided. Okay, now coming on to the next part, imagine this smaller cube. So you have all the sides or all the faces which is being painted with red, and imagine this smaller cube. So this smaller cube has how many faces painted? I'm taking only the smaller cube of this. How many faces of this smaller cube have been painted? You have paint on this side, paint here and paint here, so which means that you have 3 sides painted. So similarly here, so 1, 2 and 3. So 3 sides are painted, 1, 2 and 3. 3 sides are painted, 1, 2 and 3. So 3 sides are painted. Again, when you take this cube, you only have this face painted and the bottom painted. So you have 2 faces painted, 2 faces, 2 faces, 2 faces. And when you consider this, you have only 1 face. Okay, now remember, this is going to be your pattern for any number of cubes that you divide. Now let's say, for example, I am dividing this into 64 smaller identical cubes. I have taken a cube and dividing this into 64 smaller identical cubes. I am not going to draw a 3-dimension figure instead. So I take n cube as 64. The value of n is 4, which means that I have 4 minus 1, 3 lines across each and every face. So 1, 2, 3. 1, 2, 3. So I have 3 lines. Now all the corners is all my 3. Between the 3's, it is 2. Okay, and between, in the middle part will all be 1. If it is going to be 5 by 5, it's the same case. All the corners is all your 3, middle ones is all 2, and the center ones is all 1. Even 6 by 6, again, corners is all 3, middle ones is all 2, and the center ones is all 1. So this will be my pattern for any number of cubes that I divide. All right. So now what happens? I'm starting up to find my 3 faces painted, 2 faces painted, 1 face and no face. So to identify or to find the 3 faces painted, I have to take any one of these as a reference. So of course I will go for corner, because a corner is a place where 3 faces meet. So a corner is a place where 3 faces meet. Okay. So I'm going to take this corner for reference. Now imagine, for one corner, okay, for one corner, how many, listen, you have to listen to the question very carefully at this point of time. Now, for this corner, how many smaller cubes are there which are 3 faces painted? Okay, now we are going to find the number of smaller cubes at this corner which are 3 faces painted. So, of course, this corner has only 1 cube. It has only 1 cube, right? So, and this 1 cube is also 3 faces painted. So, my question easily satisfies. How many smaller cubes are there in this corner which are 3 faces painted? So, for one corner, you have only 1 cube which are 3 faces painted. So, ultimately, how many corners you have in a cube? you have 8 corners. So 8 corners will have how many cubes? Will have 8 cubes. Okay, again, which are 3 faces. So 3 faces painted will be. Now remember, this will never change. Unless I give 6 different colors for 6 different faces, ask you with the color combination, only at that point this changes. But otherwise, the 3 faces painted will always remain the same, because at one corner you have only one cube which are 3 faces painted. So that's not going to change. Next, to identify 2 faces painted, let's take the edges. Okay, so imagine I'm going to take this edge. You can take any edge for reference. I'm going to confirm with this edge. Right, so this is my reference edge. Now for one edge, okay, for one edge, I have to identify how many smaller cubes are there which are 2 faces painted, because I'm going to take the 2 faces painted cubes. So for one edge, how many smaller cubes are there which are 2 faces painted? So there is only one cube which are 2 faces painted, because this is 3 faces painted. So there's only one cube which are 2 faces painted. So for one edge, I have only one cube which is 2 faces painted. So how many cubes, how many edges are there? We have 12 edges. So for 12 edges, there must be how many cubes? So for 12 edges, we have 12 cubes. Okay, so there are 12 cubes which are 2 faces painted. So this must be 12 and over. Right? Now let's take one face painted. So I'm going to take, so I have taken the corner for reference, I've taken the edges for reference. Now I'm going to take the face for reference to find the one face painted. So this is the face that I'm going to take. Okay. So now tell me, for one face, how many smaller cubes are there which are one face painted? Okay, so in this face, you have 1, 2, 3, 4. 4 cubes which are 3 faces painted. 1, 2, 3, 4. Again, 4 cubes which are 2 faces painted. But my question is very clear. How many smaller cubes are there which are one face painted? So with one face painted, there's only one cube. So for one face, you have one cube. So how many faces you have? We have 6 faces. So for 6 faces, how many cubes must be there? There must be 6 cubes. Okay, there must be 6 cubes. So one face is 6 cubes. Now no face is very simple. You have divided this into 27. Okay, now let's add this. 12 plus 8 is 20. 20 plus 6 is 26. So there are 26 cubes which are at least one face painted. So which means that one face, 2 faces, 3 faces. So at least one face painted. So out of 27, 26 goes for at least one face painted. So definitely 27 minus 26 is just 1, and that must be the only cube which is no face painted, which has none of its faces painted. Now if you again imagine, you remove this block, you remove this block, you remove this block, you remove this block, the center block with the middle one will be there, which have none of its faces painted. Okay, I hope it's clear. You can just have a look at it. We can go with different other numbers. Pragati, is it visible?
Yes, ma'am. And I have a doubt of my own.
Yeah, sure.
Ma'am, you said that this the one corner, one cube, one edge, one cube is the same for all the cases. So, like in the other example you gave with 4 lines, so an n is equal to 4, and you divide it into 4 parts. In that case, we had 4 one-faced cubes. So in one face,
No,
we had
let's come for this, Pragati. I'll again come for this. Okay, that is dividing this into 64 cubes where the value of n is 4, isn't it?
Yeah.
Huh?
No,
am I on the
my
right way?
question was
Am I
like,
taking your doubt on the right path?
yeah. No, my question was, ma'am, will it differ for different numbers? So if we divide it into different numbers, the whatever the one edge equals to one cube, that part will be different.
Okay. Let's say. See, let us take the other number. Okay. Let this be. I'm taking another number. Okay, let me not, erase any one of these. So the other things are all same. So for one corner, so for 8 corners, Okay, let this be 1h. Let this. Okay, let's just remove these numbers alone. These numbers. Okay, let's remove these numbers alone, and let's remove these numbers alone. Right? Now I'm going to take a bigger cube. Again, I'm going to divide this into 64 smaller identical cubes. Pragati, let me explain this. Post which you can let me know if I've clarified your doubt. Okay, so I'm dividing this into 64 smaller identical cubes. So I'm going to equate this to n cube to find the value of n. N is 4, which means that I have n minus 1 lines across each and every face. Okay, horizontal and vertical lines across each and every face. So n is 4, n minus 1 is 3. So there are 3 lines, 1, 2 and 3. So 1, 2 and 3. Okay, this is right. So as I told you in the beginning, now this is going to be your number 3 and this is going to be your number 2 and this is all your number 1. Okay, so this is your corner. See, it is actually a 3-dimension figure. I am not going to draw a 3-dimension figure. Instead, I'm just going to imagine. So this is your corner, this is your edge, and this is your face. So we only need a corner for reference, an edge for reference, and a face for reference. So we have a corner, we have an edge, and we have a face. So 3 faces painted, you go for corners. Now you can, for one corner, see, this is my corner. So for one corner, now you can imagine. So for this corner, you have only one cube, which is 3 faces painted, right? So at this corner, you have only one cube, this cube, which are 3 faces painted. So of course, one corner will have one cube. So 8 corners will have 8 cubes. So this is what I was trying to say. 3 faces. This will never change. See, as I told you in the beginning, the 3 faces painted will never change unless, okay, I'm going to give you a question like this. You have a cube. All the 6 faces are 6 different colors. Let's say blue, green, pink, yellow, purple, red. So you have 6 different colors. Okay, now I'm going to ask you a question like one corner, how many smaller cubes will be there which have blue, purple and pink? So at that point of time, the answer for 3 faces painted changes unless it will never change. Okay, it is going to be the same for whatever, if it is going to be bicolored or tricolored, it will just be the same. If you are taking a cube in such a way, so these two colors, these two faces are green, all the other faces are pink. The answer is just the same. 3 faces painted will be same. Okay, and if you take, say, 3 different colors, brown and brown, pink and pink, yellow and yellow, maybe at that point of time, the number of 3 faces painted will change. Okay, so otherwise, the number of 3 faces painted will never change for a single colored cube. Okay, you're going to paint on all the sides with one single color, so the number of 3 faces painted will not change, right? So this is what I was trying to say. So one corner you have only one cube, which are 3 faces painted. So for 8 corners you have 8 cubes. Simple. So for one edge, now I'm going to take this edge. So how many smaller cubes are there which are 2 faces painted? Remember, you have to consider the 2 faces painted here. So this is one and this is one. So for one edge you have 2 cubes. So for 12 edges you must be having 12 into 2, 24 cubes. You must be having 24 cubes. So the number of 2 faces painted will become 24. Okay. Now for one face, so I'm going to consider this face. So for one face, how many smaller cubes are there which are one face painted? So here we are going to focus on one face painted. So you have 1, 2, 3 and 4. So there are 4 cubes which are one face painted. So for 6 faces, it must be 6 into 4, 24 cubes. Okay, so one face will be 24. Now, the last part is simple. You add 24 and 24 is 48. 48 and 8 will be 56. You have divided into 64. So 64 minus 56 gives you 8. And that's the number of no faces. Pragati, is your doubt cleared?
Yes, ma'am. Thank you. Thank you so much. It's clear, ma'am. Thank you so much.
All right, all right. Okay, so we shall try with different other numbers. Okay, now let's take so let's take 125. Okay, let's take 112. Let's take 125. So suppose if I'm dividing this into 125 smaller identical cubes, so the value of n is 5. So if the value of n is 5, my lines should be n minus 1. So 1, 2, 3, 4. 1, 2, 3, and 4, right? So this is all my 3. This is all my 2. And these are all my 1s. Okay, this is all my ones, right? Now let's say again for one corner, I'll erase all these numbers. So this is going to be different numbers as such. Okay, so for one corner, of course, there's only one cube. If you can witness, okay, if you can witness for 27, for 64 and 125, it was only the same number. So for one corner, it's only one cube. So 8 corners, you have 8 cubes. So 3 faces painted will always remain 8. Now for one edge, see for one edge there are 1, 2, 3. So there are 3 cubes, and for 12 edges it must be 12 into 3, which is 36. Okay, so this is 36. Now for one face it's 1, 2, 3 and 3, which is 9. So there are 9 cubes. See, I'm going a little fast because I am supposed to give you another new technique in this. So one face 9 cubes. So for 6 faces it must be 6 into 9, which is 54 cubes. So this must be 54. Now you add, so I'll take this 4, put it here. This becomes 40 and 15, 90, 98. Okay, I'm just doing nothing else but adding. 54, I'm putting it here. So this becomes 40, rounding off. So 50 and 40, 90, 90 plus 8 is 90. So I've divided this into 125. 98 and 2 gives you 200 and 25. So 25 plus 2, which is 27. So you have no faces painted, which is 27. Okay, that is 125 minus 98 gives you 27, and those 27 cubes must be there which are no faces painted. Okay, I hope it's clear. Now, if you could just remember or imagine, so we are taking the values of n. See, it is just 125. So you can put a square, fine. Now, suppose if I'm going to give you a number like 1331 or 1728. Okay, so that's going to be a very challenging part. So which means that we are going to generalize something here. Okay, so generalize in sense, I know this is my value of n. Okay, I know 1, 2, 3, 4, 5. So this is actually 125. So 1, 2, 3, 4, 5. This is my value of n. So in all the 3 faces painted, it's just the same, which is 3. So I'm not going to bother much about it. But my 2 faces changes with each and every case. So for 2 faces, what I'm doing is nothing else but I'm taking the reference of the edge. Edges are 12 in number. So I'm just going to do, see what I'm doing is I'm taking this edge for reference. I'm counting the number of 2's. So to count the number of 2's, I'm excluding these 2. So when I say this is n, and I'm excluding the first and last in each cases, so isn't this n minus 2? You understand? See, this is my value of n. 1, 2, 3, 4, 5. This is my value of n. And in every case, okay, to find the number of 2 faces painted, I'm considering the edges. Okay, how many smaller cubes in edges, out of which I remove the first and the last cube because the first and the last one are 3 faces painted. So to consider the two faces painted, I'm removing the first and last one and generalizing only these 2, which means that this is my n minus 2. So n minus 2 I'm multiplying with what number? With the number of edges. So number of 2 faces painted will always be 2 into n minus 2. Okay, let me write this here. Okay, number of 2 faces painted will always be 12 into n minus 2. But remember, this 12 is only for a single colored cube. Suppose if I change, if I'm going to give you a bicolor or tricolor, number 12 may not be the same. It changes according to the question. You have to identify the edges in line with your question. So draw the cube, identify the edges in line with the question, and then substitute this. But ultimately, your 2 faces painted will always be related to n minus 2 into the number of edges. Right. Now, let's say 3 face or 1 face painted. So to take the 1 face painted, we are doing nothing else but You are multiplying this and this, which is n minus 2 the whole square. Okay, so this is again nothing else but n minus 2 the whole square. Here, n minus 2 the whole square, and you are taking the reference of a face. So one face is n minus 2 the whole square. You have 6 faces, so this is 6 into n minus 2 the whole square. So one face will always be, okay, one face painted will always be 6 into n minus 2 the whole square, where 6 is your number of faces. And coming on to the no face painted, if you could observe, your no face painted is nothing else but n minus 2 the whole cubes, because you are taking, remove this part. The center one is your n minus 2 the whole cube. So this is your n minus 2 the whole cube. So your no face will always be your n minus 2 the whole. Okay. See, the reason why I didn't give you this in the beginning, just because you have to I understand the logic. Okay, unless you understand the logic, these numbers is not going to play a major role here. Right? Now let's take, see, I am not now, I mean, we have completed with 125. Let's just cross verify and see. So I am not going to draw any cube. So my n cube is 125. The value of n is 5 for the same problem. Okay, for the same problem, we all know the 3 faces is 8, so I am not going to disturb that. Now to identify the 2 faces painted is 12 into n minus 2. N is 5, 5 minus 2 is 3, 3 into 12 is 36. I'm getting the answer. Okay, so to know the one face painted, 6 into n minus 2 the whole square. N is 5, 5 minus 2 is 3, 3 square is 9, 9 into 6 is 54. We got the answer. One face is 54. See, this answer we got by drawing the, the square, drawing the cube, giving all the numbers and identifying according to your conventional logical method. So no face is n minus 2 the whole cube. 5 minus 2 is 3, 3 cube is 27. So ultimately you got the answer. Okay, so if it is going to be, if I'm going to divide this into 216 smaller identical cubes, so this becomes your n cube. The value of n is 6. So to find the number of 3 faces, it is 8. 2 faces is 12 into n minus 2, n is 6. 6 minus 2 is 4. 4 into 12 will be 40. So 2 faces will be 40. Okay, one face, 3 face, 3 face is just 8. So one face is again 6 into n minus 2 the whole square. N is 6, 6 minus 2 is 4, 4 square is 16. 16 into 6 is what you're supposed to find. So 16 into 6 is 36, 396 will be your answer. So one face is 96. If you could draw a square, okay, find by the usual logical way, it will give you the same answer. So one face is 96. So to identify the no face cubes, no face is n minus 2 the whole cube. 4 cube is 60. Okay, you need not draw a square, you need not identify number 3, number 2, number 1 or so. You can directly give the answer with the help of these two faces, one face and no face. Is it clear? Pragati, any doubts in your chats? I mean your live chats?
No, ma'am, no doubts so far.
No doubts. All right. So let's move ahead. Now, all right. Now let's say, suppose if the question changes, I am not, erasing this. Let me just erase this way. Suppose if you have a question like this, there's a cube. Okay, you are coloring the cube in such a way that let's take two colors. You have red here. Okay, then green on this side, green this side, green this side, and green on the corner. Okay, so this is how the cube is being colored. So you are taking a cube, you are giving a red and red on both the sides, all the other sides are green color. So after giving all the cubes, drying it, you are dividing this cube into, let's say, 125 smaller identical cubes. Okay, so you are dividing this cube into 125 smaller identical cubes. Now what happens after dividing? You're supposed to find the number of smaller cubes which are two faces painted. I'm writing down the question. I mean, you can post the answers. Two faces painted which are green and green. Okay, and two faces painted which are red and green. Okay, one face painted with only red and one face painted only green. Right? So three faces painted, of course, is not going to change because you have green two sides and red on three. I mean, red on just one side, so that's not going to change. It is just the same. And no face painted is also not going to change because none of its faces are painted, so that will be the same ones. Otherwise, the changes that are possible is only with these four questions. Two faces painted which are green and green, two faces painted which are red and green, one face painted which is only red, and one face painted with only green. So, by just saying two faces painted, you just cannot take 12 into n minus 2. It's not that way. So, two faces painted with green and green, which means that you have to identify the edges which has green and green on both the sides. Now, this will be one of the edge which has green and green. This will be another edge, green and green. This will be another edge, and this will be another edge. So, you have only four edges which has green and green. So, of course, two faces painted will always go with n minus 2. So, this is nothing else but 4 into n minus 2. Okay, next, two faces painted with red and green. So, you have to identify again the edges which has both red and green mixed. So, 1, 2, 3, 4. Similarly, on the other side, 5, 6, 7, and 8. So, you have 8 edges with red and green. So, this becomes 8 into n minus 2. Okay, now coming on to one face painted, it's with only red. So one face painted with only red is red has only two faces. So this is, see, one face is always n minus 2 the whole square with the number of faces. So this is n minus 2 the whole square. Let me write the numbers here. So this is 4 into n minus 2, this one. And this is 8 into n minus 2 here. And this is n minus 2 the whole square into 2. Because there are only two faces which are with only colored with only red. So 2 into n minus 2 the whole square. And this one here will be 4 into n minus 2 the whole square because there are 4 faces with only green. So 1, 2, 3, 4. 4 faces with only green. So this is 4 into n minus 2 the whole square. Now you know the value of n. So n cube is 125. So the value of n is 5. So if n is 5, you can directly just substitute and get the answer. 5 minus 2 is 3. 3 into 4 will be 12. Okay, 5 minus 2 is 3. 3 into 8 is 4. Then 5 minus 2 is 3. 3 square will be 9. 9 into 2 is 18. And 5 n is 5. 5 minus 2 is 3. 3 square is again 9. 9 into 4 is 36. Okay. So even though the problem looks little complicated, once you know the concept very well, it is very easy to find the answer. So ultimately, when you are planning for any competitive or campus placements with this technique, you can definitely save a lot of time. Okay, fine. So this is all about your cubes. So again, see, this is the bicolored cube. I've given two different colors. You can also go with tricolored cubes. So you can also have tricolor cubes, but that's again the same procedure. So you have to identify the edges and faces accordingly and draw I mean, it's not a formula, but draw the hint in accordance with the nature. Okay. Now, in the beginning of the session, Shanmuga Priya ma'am was talking about, clearing with the time concept. See, I would definitely say that, right, I told you in the beginning, it is not just a overnight process. You're learning aptitude today, tomorrow you become an expert. No, it's not that way. Okay, so anything practice, you must have heard a very a very famous quote: practice makes a man perfect. So it's the same way in this case also. So you practice a lot of problems. Okay, you will understand the tactics inside and get to know. See, let me give you one example. Okay, let me give you one example. Two persons are there whose ages are in the ratio 2:5. Okay, two persons are there whose ages are in the ratio 2:5. After 4 years,
Hello, ma'am.
okay, or after 10 years, their ages will be in the ratio, let's say, after say 3 is to again 10. Okay, after 10,
Hello,
I see,
Shabana, ma'am.
I'm just drawing the random
Shabana, ma'am.
numbers. This numbers doesn't go with any logic. Pragati,
Hello.
you're saying anything?
Yeah, Shabana, ma'am. This is Shanmuga Priya here. Sorry for interrupting you.
Yes,
Madam,
yes, ma'am.
by 11:30 we have another session. So sharp by 11:30 shall we wind up, madam?
Yeah,
So
yeah,
that's
sure,
what
ma'am, sure. I am
we have.
actually done. I'll just give free inception. I mean, just few inceptions about what you were talking in the beginning. So with that, we can close.
Yeah, by 11:30 we have another session. Now the time is 11:20. So that's what, ma'am. Yeah.
Yeah,
Thank
sure,
you,
ma'am.
ma'am.
Sure, sure. Yeah,
Yeah.
all right. So, I mean, coming on to here, this problem, see, I've just taken the random numbers. It's not, this problem doesn't go with any logic. So, similarly, in the initial, they are in the, I mean, the present ages is in this ratio. Maybe after 10 years, the ratio is this. Now, when you look at the options, you have options like this, 54. Find your question is this, find the present age of, present age of B. Okay, so your options is this: A, option B is 60, option C is 66, option D is say 63. Of course, okay, you're going to find the present age of B. Now you identify the present age ratio is this. This is your present age ratio. Okay, so and you're going to find the present age of B. So B is this part. So it must be something related to 5. It must be a multiple of 5. Okay, it must be, I mean, the percentage of B must be a multiple of 5. So, which of course you go with this as your option. You need not calculate anything else. Okay, so the moment you find the options, moment you understand the question, you can give your answer. But how does this presence of mind comes? Only when you practice. Okay, so only when you practice a lot of problems, you come across many things, you will have this kind of ideology. Okay, and the other point that she was asking is about the topics. When it comes to topics, you have lot of topics available. Say, I would never, divide aptitude and quantitative into different topics, because I have seen a problem which actually, see, I'll give you one example. Let's say there's a truck that moves with some speed, okay, and it covers some distance in a particular time. So the speed increases by some percentage, okay, some percentage. The distance also increases by some percentage. Okay, what will be the percentage change in the time? What will be the percentage change in the time? Now, which category will you divide this problem into? Will you go with percentages or will you go with time, speed, and distance? Okay, so that's just because, yeah, I'm just trying to give an example, because aptitude as a whole is about logical thinking. The main topics that you have to consider is that you have to be strong in numbers. So numbers play a very, very major role. So you have numbers, you have HCF, LCM, you have APGPs, and you have, ages, averages, time, speed, and distance. And then you have probability, permutation, rate and work, you have chain rule, proportionality, and then you have allegation rule. See, I'll tell you another problem. There are 1,000 kgs of, there are 1,000 kgs of sugar. A merchant tried to, sell the sugar at 8% profit on one side, 18% profit on the other side. That is some particular weight. I mean, that's some particular quantity. He sells at 8% profit, and the other particular quantity he sells is 18% profit. On the whole transaction, he gains 14% profit. Okay, so how many kgs does he sold on 18% profit? So will you take it in percentages or can you take it in allocation? So of course you can go with the allocation rule. So problems are all interlinked to each other. All the problems are interlinked to each other, provided you understand the basic concepts very well. You become strong in your basics. You can solve any problems that comes in your way. Okay, so then you have numbers, you have monies, and then you have a lot of when you come for reasoning, you have problems like this, which we could just gone through, analytical reasoning, and then you have calendars, you have cubes, and you have lot of problems like that, right? So ultimately, I'll give you a few websites which will give you a good a good number of problems you can go with. You can refer phase prep. I'm sorry, you can refer phase prep. So this phase prep recently has a good number of quality problems. So they have lot of online tests also. You have lot of online tests available. Okay, you have lot of online tests available. You can take the test, know the know the solution, and just see your scores also. So that will be a good practice. You also have IndiaBix, so you must be knowing this. IndiaBix is a very old website. You have IndiaBix. You have a forum called Math for M for Math. You have a forum called M for Math. Okay, you can go through that also. That's again a forum. You have lot of problems being discussed there. Okay, so there are a lot. See, I came across a very a logical statement recently. If you have an internet, if you have a mobile phone with you, you can learn anything in the world. Okay, so today this pandemic has opened a biggest gateway for this particular statement. If you have internet and if you have a mobile phone or a system or any gadget with you, you can learn anything in the world. Nothing is nothing you can you actually have to pay something for it. So it's all comes in your way in a very easy manner. Okay, so it's all about your intention. And also I would like to I would like to stress you that you have lot of opportunity towards competitive exams. You have IBPS, as I told you in the beginning of the session. You have banking professions, you have non-banking layer, you have group exams, TNPSC, UPSC, so SSC, they are combined graduate level examinations. You have combined higher secondary level examinations. Okay, so you have lot of competitive exams are there, so please go through it. All you have to know is this particular thing. So if you know what are the the concepts which has been involved, it is fair enough that you can just crack and walk through. Okay, so you can come back for any questions. Pragati, if you have any questions in the live chat also, you can post it.
Ma'am, there are actually no questions coming in the live chat, but
Okay.
it was very informative, ma'am. I really understood the whole cube concept, and I didn't know it would be so simple. When you first told us about the cake question, I was completely clueless. And
Okay.
so it's
Okay.
all about.
I'm sorry, Ji. Thank you so much that you reminded me. So what can be the answer for the K question? I'm talking for the entire, I'm asking for the entire people. See, the K question is like you have 512 smaller identical cubes. I forgot to give you the answer. So ultimately, the number of smaller pieces of cube, which has none of its sides creamed, is nothing else but n minus 2, the whole cube. Where your n was 8, n minus 2 is 6, 6 cube is 216. So 216 guests would have received cakes with none of their sides creamed. Thank you, Pragati. Thanks for reminding.
Thank you so much, ma'am.
Yeah. So best wishes for everyone here. Please do learn it. Do not take anything easy. Nothing easier is achievable. So all the very best for each and everyone here. Thank you, ma'am. Thanks a lot for this opportunity.
Thank you, Shabana ma'am. It was a wonderful session, Shabana ma'am, and at last you answered all of my questions. Thanks a lot for giving the websites also. It will be very useful for our students to practice offline. And one request from my end, Shabana ma'am, if you could share some sample aptitude question papers via email to me, it would be of great help for our students as we are marching towards a campus placement drives this month. So that's one request from my end. And thanks a lot, students, for your active participation for the past 6 days. We have posted our feedback link in the YouTube chat box. Please do fill in the feedback and send us before 12:30 today, 12:30 p.m. today. So once you send us a feedback, we'll send you the e-certificates, which will take a minimum of 10 to 12 days of time period. So thanks a lot, students. Thank you, placement team, placement coordinator, ma'am Sashi ma'am, and our placement student secretaries Vedika and Pragati. Thank you, technical team Tamarai and Naranjana, for this wonderful coordination. Thanks a lot, all of the students who have actively participated in the past 6 days of this workshop. Thank you, Shabana, once again. Thank you.
Thank you, ma'am.